We've been working on a fairly thorny problem about calculating the cheapest way that we can run an electric cable from a power station to an offshore island, given the fact that the wire can be run underground at a certain cost, but a higher cost if we're going underwater. So we've calculated the geometry of the situation and come up with a cost function. And in the last video, we calculated the derivative of that function. So now that we've done that, we can do the last part, which is actually calculating the minimum amount of cost and the way the situation would need to be set up in order for that to happen. All right, so here's our derivative function. So remember, to calculate a maximum or a minimum, we need to set that derivative equal to 0. So we want negative 30 plus 50x over the square root of x squared plus 1 to be equal to 0. And we want to figure out which value or values of x make this the case. Okay, so first thing we'll do is we'll move the 30 over to the other side. So that becomes 50x over the square root of x squared plus 1 is equal to 30. And now we can move this over to the other side by, if we want to think of it as cross multiplying. So 50x times 1 is 50x is equal to 30 times the square root of x squared plus 1. Okay, this is getting prettier and prettier as we're going through, so at least we've got that going for us. The next thing we could do is if we squared both sides of the equation, this square root sign would go away. So that seems like a good idea. So 50x, if we square that, we get 2,500x squared is equal to 30 times 30 is 900 times what was in the square root, which is x squared plus 1. All right, well, now we can use the distributive property to clear out these parentheses. So 2,500x squared is equal to 900x squared plus 900. And this is starting to look like something that we can solve for x. So it's really nice that we've got x squared is our only variable. We can subtract 900 from both sides. And so 1,600x squared is equal to 900 is all that's left on that side. So we'll divide both sides by 1,600. And that tells us that x squared is 900 divided by 1,600, which we can simplify as 9 over 16. But we want to figure out what x is. So to figure out what x is, we'll take the positive square root of both sides of this equation, and we get that x is equal to, it doesn't make sense to talk about a negative value because a negative value of x would say, I want to run the wire over here before going over, and that doesn't make any sense at all. So the square root of 9 over 16 is equal to the square root of 9 divided by the square root of 16, which is equal to 3 over 4. Phew. All right, so let's take this and go back to our situation here and see what we've got. So what we're saying is that x is equal to 3/4. What does 3/4 represent? Well, 3/4 represents the distance here of the wire that we want to lay. So I'm sorry, this is the amount of the wire that we want to not lay. So we're saying that the amount that we should run the wire underground is 4 minus 3/4, which will be 3.25. So we're going to run 3.25 miles underground. And let's pop out our calculator for this. So if this is 3/4 of a mile and this is 1 mile, then this will be 0.75 squared plus 1 squared. And if we take the square root of that, it's saying that this distance right here is 1.25 miles. All right, so we're running the wire 3¼ miles underground, and then the section that's going to be underwater has got to be 1.25 miles. So the problem they ask us is to find the minimum cost. So we've got to do this calculation here. So this is 3.25 miles times 30,000 per mile for underground plus 1.25 times 50,000. All right, so 1.25 times 50,000 is equal to $62,500 to lay the underwater part, and 3.25 times 30,000 to lay the underground part, which is $97,500. So the grand total for our project is $97,500 plus $62,500. So it's a grand total of $160,000 to make this project work out. All right, that was a lot. Let's take a look. Just for kicks, let's go take a look in Geogebra and see if it kind of agrees with the answer we came up with, because that was a lot of work and there's a lot of spaces where that could go wrong. So let's pop over to Geogebra. So let's see, where is my Geogebra screen? All right. So Geogebra is going to look like this. All right, so I've got my function here that we came up with in the first video, 120 minus 30x plus 50 times the square root of x squared plus 1. And when I put that in, this graph doesn't show up here at all. And the reason for that is that I've got to zoom all the way out. I got to do some zooming here. Whoa, there's the graph over there, because this is an expensive project. So here's what the function looks like, and we can see the minimum value is going to be right down here somewhere. So let's zoom in on here and see if it matches our idea that it was going to be 3/4 of a mile. So there's 0.75 miles right where our minimum is. And what's the cost of that? That is equal to $160,000. So that was a ton of work. It was a lot of geometry and then some calculus and then some algebra at the end of it. But what we were able to do is we were able to solve a really, this is the kind of real world problem that a civil engineer would be really interested in doing. How can you make sure that this project can be done as inexpensively as possible? And so that gives you some idea of the power of optimization and the power of the math you've been learning in school so far.